Hello, today we're gonna learn how to add vectors or how to find a resultant of several vectors. So we're gonna look at three specific problems. Okay, let's get started with problem number one. Here we are given three vectors and we have to find the resultant vector. First, let's draw them again and identify the x and y components of each of these vectors. So if you look at F3, it only has x component, right? So let's assume this is y-axis and this is x-axis. So it only has x component. So we're gonna leave this one alone for now. Start with F1. F1 has x and y component. So x component is gonna be F1 times cosine 60, because if you can imagine this to be a right triangle. So this is the adjacent side and this is a hypotenuse, F1. So f1x is going to be just f1 times cosine 60, or cosine of this angle, but we're going to put a minus sign in front of it because it's pointing in the negative direction. For f1y, you can imagine f1y to be the opposite leg of this right triangle, and again f1 is a hypotenuse, so f1y would be f1 times sine 60. In this case it's positive because it's pointing up. Same thing with f2. f2x is going to be f2 times cosine 60 because this angle is 60 and this is a right triangle, but we put minus sign because it's pointing in the negative x direction. For f2y, we have f2 times sine 60 because it's the opposite side of this right triangle and this is your hypotenuse, and we put minus sign in front of it, this. Okay, so now we decomposed f1 and f2 into x and y components. So now let's try to find the magnitude of the resultant vector. Okay, so how are we gonna do it? First, let's write down and calculate each of these components. So for f1x is going to be -1, f1 cosine 60, we are given these values. So cosine 60 is 1/2, sine 60 is √3/2, and we can go ahead and calculate x and y components of the f1. In a similar manner, we can calculate x and y components of f2. It's going to be negative f2 times cosine 60 for the x component and negative f2 times sine 60 for the y component, and cosine 60 is half again, and then sine 60 is 3/2. If we proceed and calculate this, we're going to get negative 4f for x component and negative 4 times √3 times f for y component. Now we have to find the x and y components of the resultant vector. How are we going to do this? Well, for the x component, it's going to be f3, right, plus f1x and f2x. And this is going to give us the x component of the resultant vector. So we're just adding all the x components together. So this one is 2f, this one is minus 5f/2 as we found here earlier, and for the x component of the f2 is minus 4f. If we add it up, we get minus 9f/2. In a similar manner, we proceed to find out what is the y component. For the y component, we only have this 2, right? This one is a positive, so we have here 5√3f/2 minus 4√3 f, and this gives us this. Now, how are you going to calculate the magnitude? Well, so if you have x component and you have a y component, the magnitude is going to be just square root of their squares because of the Pythagorean theorem. Just in a similar fashion that we did here, right? So if you add x component of this and y component of this by squaring them and adding them, you're going to get actual lengths of the f1, right? Because this is nothing but a right triangle, because you can translate this to here and it forms a right triangle. So the resultant force is just a square of its x and y components summed together. And we already calculated x and y components. If we square this, both of them have f, both of them have 2, so this is going to give us f squared over 4, f squared over 4. We can take this out of the square root, which is just going to give us f over 2, and we just left with square of -9 and square of -3 root 3. Well, this is going to give us 81, 27, and 108 is 108 is going to be just you can write it as 9 times, I guess 9 times 2 times 9 times 4 times 3, right? So we get 3 out, we get 2 out, 2 and 2 cancels out, so you end up with 3 root 3f. I hope this is clear to everyone. So our answer, our magnitude of the resultant vector is 3 times root 3f. Let's look at the second problem. Okay, so in this case, we are again given 3 vectors and we have to find the resultant vector. Okay, so not only the magnitude, but also the vector itself. Well, again, what we're going to do is we're going to draw this and identify x and y components of each of those. Well, f3 only has x component, right, pointing in the negative x direction, and f2 is only have a y component, which is pointing in the negative y direction. So the only one that has both x and y component is f1. Again, f1x is going to be f1 times cosine of this angle, right? Because this is adjacent, and this is your hypotenuse. So f1 times cosine 37 gives you f1x. And your opposite is just going to be f1y, because this length and this length is similar. So f1y must be then f1 times sine 37. Now, let's go ahead and calculate this. So f1 is given as 25, and we can calculate f1 times cosine 37, and cosine 37 is 0.8. So you end up with 20 newtons, and sine 37 is 0.6. So 25 times 0.6, you end up with 15 newtons. Now, let's calculate x and y components of the resultant vector. Well, again, for resultant vector, as we did earlier, it's going to be just f1x plus f3. f1x is 20 newtons. We just calculated here. And this is f3 is minus 8 newtons because it's pointing in opposite direction. So f1x comes out to be 12 newtons. Y component of the resultant vector is going to be f1y plus f2. So you have 15 newtons for f1y and minus 6 newtons for f2. You end up with 9 newtons. Well, we're going to find the resultant. We're going to find the magnitude of the resultant vector in a similar fashion as we did earlier. We just square its components and add them up because of the Pythagorean relations, right? So you square 12 and then 9 and sum it up, you get 225, which is 15 newtons. Now, x component is 12 newtons. Y component is 9 newtons, so it's going to be 12 newtons. So a resultant for the resultant vector, the x component is going to be 12 newtons this way and 9 newtons this way. If we're going to draw the vector itself, that's what your resultant vector is going to be. Yeah, if you measure this distance, it should be 12 newton, and this distance should be 9 newtons. And this is your resultant vector, and the magnitude of this resultant vector is 15 newtons. I hope this is clear to everyone, and the answer is the magnitude is 15 newtons, and the vector is lies in the first quadrant and shown as this one. Now let's look at the final third question. Here again, we are given three vectors, f1, f2, f3, and we have to find the resultant vector. So, what we gonna do? We're gonna break f1 into its x and y components, and note that the x component is going to be a negative because it's pointing in opposite direction to x. Y component is positive. Similar for f2, you have negative x component and also negative y component because x component of f2 is pointing in negative x direction, and y component of 2 is pointing in negative y direction, right? And it's similar to what we've done earlier. So f sub 1 x is going to be equal to negative f1 times cosine 37 because this angle is 37. f1 sub y is going to be positive because it's pointing in positive direction. Positive f1 times sine 37. And the same thing goes for the second vector, right? Now, let's calculate the magnitude of the x and y components of these two vectors, f1 and f2. Well, since cosine 37 is 0.8 and sine 37 is 0.6 and f1 is 10, we get minus 8 newtons for the x component of the f1 and 6 newtons for the y component of f1. In a similar manner, by noting that cosine 53 is 0.6 and sine 53 is 0.8, we get minus 3 newtons and minus 4 newtons for f2 sub x and f2 sub y, respectively. Next step is to find the x and y components of the resultant vector. Well, we just have to add all the x components. So we have f3 plus f1x plus f2x, or in other words, it's going to be 13 minus 8 newtons and minus 3 newtons, which works out to be 2 newtons. For the y component, we do the same thing, but we only have y components of f1 and f2 to deal with. f1y we already know is 6 newtons, f2y is minus 4 newtons, so we get again 2 newtons. So the magnitude of this resultant vector will be just the square of its components added together and square rooted. So it's 2 square plus 2 square, or 8, which works out to be 2 times root 2 newtons, or 2.8 newtons. Now, we know the x component is 2 newtons and y component is 2 newtons, right? So you have a vector whose x component is 2 newtons in this direction, and y component is 2 newtons in this direction, and x component is also 2 newtons in this direction. So resultant vector should be in this direction and should make 45 degree angle with its components. So this is going to be your resultant vector, right? So this is 2 newtons, this is 2 newtons, and by Pythagorean relation you get this to be 2.8 newtons. That means this angle is 45 degrees. So our answer is resultant the resultant vector is in the first quadrant, and it makes 45 degree angle either with x or y axis, and its magnitude is 2.8 newtons, and that's the answer. I hope these 3 questions were clear to you and you learned something today. Thank you.